All right, we're given an array of 0 to n minus 1 numbers of distinct numbers, except there's one duplicate. So say we have say we have 0, 1, 2, 3, 4, 4, 5, 6, 7, and 8 in our array. Then we see that the 4 is the duplicate, so we need to find that. So one thing that we can use to our advantage is knowing that the bounds of this array are 0 to n minus 1, which means that we can actually just do some simple math to solve this problem in constant time without using any, not constant time, but in n time without using any extra space. And actually we can just, I think we can actually say the bounds are from 1 to n minus 1. But what we do know is that we can just do basic math. So one thing we could do would be to add all of them up and see what they actually are equal to and what the sum of all of them are. And then we could also subtract what they should be, assuming there wasn't a duplicate number. So that is one approach. What we can also use is a formula to do that as well. So we could use the n times n minus 1 over 2, which would give us the sum of everything that we're expecting. So that's an option 2 to use that. But what we're going to go ahead and do here is just a loop. So find the dupe, and it's taking in an array of integers. Okay, and then at the end it's going to return the duplicate value. So what we're going to do is first check to see if the array is null or anything like that. And if that's the case, we'll throw an exception. Or actually, in this case, we'll just go ahead and return -1, since that's what we're going to return if we don't find an answer. And then we would say, we could just do a loop. So for I is less than array.length, I plus plus. And what we can do while we go through this loop is we can actually add and subtract at the same time, because what we're ultimately going to do is have our actual sum, and we're going to subtract the expected to get our answer. So we're going to kind of do that at the same time. So to do that, what we can do is say, is just have a sum and or answer, and that is going to equal array at I for our actual array minus I, which would be what we are expecting it to be, because I will go through each one of the arrays as if there's nothing missing. And then at the end, we should be able to just return answer. So, oops, return answer. We can also say, we should probably say if answer equals 0, then there's nothing duplicate. So then we would return -1, else return answer. Okay. So let's go ahead and walk through this. We have I to keep track of, and answer to keep track of. So we go in and let's number these so that it's, okay. So we go in and I starts at 0 and answer is going to equal array at I, which is 1 minus 0. So answer is currently 1. And then I++, it's still less than the length. So it would be answer plus equals, I should say, array at I minus I. So then we get 2 minus 1, which is 1. So now answer is 2. I++, I is 2. That's a 3 there. So answer plus equals 3 minus I. So that's a 1. So we now have 4. No. 2 is 3. Okay. And then I is 3. 3 is here. So answer plus equals 4 minus 3. So this is now 4. It's a 4. Answer plus equals 4 minus 4. So answer is still 4. We get to 5. And answer plus equals 5 minus 5. So we're still at 4. 6. 6 is still less than the array length. 6 minus 6 is 0. So we're at 4. I is 7. That's still less than the array length. So 7 minus 7 gives us 0. So we're at 4. And then I++, I is 8, A is less than the array length. So then we go in, answer plus equals 8 minus 8, which is 0. So we're at 4, then I becomes 9, which is equal to the array length. We get out of our for loop. If answer equals 0, then return -1. That's not the case. Else return answer, which is 4. And 4 is indeed our duplicate number. So this solution is going to have a complexity of O of n. And it also handles overflow quite nicely. So if we had a really long array, answer wouldn't get, we wouldn't have variables that would get really long since we're adding and subtracting at the same time. And it uses no additional data structures or space.